Question 19 talks about n cross n matrix A with diagonal entries alpha and other entries beta. A can be written down in the form D plus U V curl, where D is diagonal and U and V are n cross 1 vectors. Based on this, we have to determine a condition for which n A can be non-single. This is a very well-known matrix. I believe all of you have seen that matrix at a point of time. And you can even take the determinant of this matrix as a result. Like, I can share with you, like, for my own jam preparations, I used to take the determinant of this matrix with the elements as A and the diagonal elements A and the other elements B as a result, and I used to remember it. I still remember it now. So because this is a very useful matrix and a lot of calculations. Okay, so I'll essentially be showing you kind of the derivation of this. But anyway, you can derive it in the other way as well, like in the usual way we compute determinant in high schools, like adding a row, taking out a common term, or we can do it by this method, which is a method partition. So A is this matrix, which can be written down in this form: alpha minus beta in the diagonal, and beta. A vector of beta is n cross 1 vector, and a vector of ones, which is 1 cross 1. So it's D plus U V curl, as mentioned in the question. This is the form of D, U, and V. And now determinant A comes out to be determinant D plus V curl into adjoint A into U. This is a result I'm using here. And it can actually be written down in this form. You can try it out yourself by, say, adding all the row elements, and in the first column you'll be getting alpha plus n minus 1 into beta. You can take that out as common, and then you can find out the determinant of the resultant matrix. So determinant A not equal to 0 means alpha minus beta into alpha plus n minus mod of alpha plus n minus beta not equal to 0. So B is the correct option. Okay. Oh, sorry, this will actually be adjoint of D. Sorry. Yeah. So you can obtain determinant A in this form. This is a result. Or you can do it in the usual way. You can add up all the row elements in each row and take alpha plus n minus 1 and beta common out, and you will be basically having 1 in the first column, and then you can cancel out and obtain the determinant, like in the way we usually do. We usually obtain the determinants without expressing in a particular form. Okay.
Hello guys, welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI Mstat, and CMI Mstat Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISI Mstat, and CMI Mstat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
So this is question number 21. Which of the following statements are true about the power series given? Fx is equal to summation x to the power p, where p is a set of prime numbers. 21. I have written down fx as summation x to the power p, which can be written in the form summation an x to the power n, where an is 1 if x belongs to primes and 0 otherwise. Oh, sorry. This will actually be n belongs to primes. Yeah. So we know when we have a power series of this form, we can obtain the radius of convergence, which is r, by the formula modulus of r is equal to 1 by limit superior n tends to infinity mod n to the power 1 by n, which is the Cauchy-Riemann form, the Cauchy form. And here, obviously, an can take only two values, 1 and 0. So an to the power 1 by n can again take two values, 1 to the power 1 by n and 0. And the supremum is obviously the value taking when n takes a value 1, and it's 1 by 1. So it's basically 1. So the radius of convergence of the power series comes out to be 1. Next up is fx. Let me get back to the options once. So the first two options talk about the value of r, and the second two options ask us whether the power series satisfies two given inequalities. Obviously, the left hand side is trivial. The fx is obviously greater than or equal to 0 for 0 less than or equal to x less than 1. We just have to check the right hand on it. So fx is equal to x squared plus x cubed plus so on, which is less than or equal to x squared plus x cubed plus x to the power 4 plus x to the power 5, because we are essentially this line, the series in this line has some essential additional positive terms from the first line. So this is obviously greater than, and this is equal to x squared by 1 minus x by the formula of the summation of the infinite GP series, and this converges because x belongs to 0 less than or equal to x less than 1. So this is essentially the inequality in option C. Okay, and D is not correct because you can observe after trying to write it down in this form, x squared plus x to the power 4 plus x to the power 6, after a point that this inequality won't necessarily hold, and it can be a very good exercise for you to try to find out a value of x which particularly does not satisfy this inequality. You can check it out yourself. So B and C are the correct options, and you can definitely try out D.